This first lesson is going to deal with matrices. And it's possible that you've seen matrices before somewhere along the lines. Again, a matrix is a rectangular array of numbers, symbols, or expressions arranged in rows and columns. And the things that we're going to talk about in this section are matrix terminology, how to add, subtract, multiply, compatible matrices, and we'll talk about what it means for them to be compatible. We're going to find the inverse of a matrix in a later section, apply some of the properties of matrices, and solve systems of equations using matrices, which is one of the reasons that we deal with matrices, is that they are very powerful tools in solving systems of equations. So let's go ahead and get started with our first section, which is basic operations on matrices. The plural for matrix is matrices, and I already mentioned the definition of a matrix. It is a rectangular array of numbers, symbols, or expressions arranged in rows and columns. And those rows and columns are what we call the order or the dimension of the matrix. We always measure a matrix, if you will, or define it as the number of rows by the number of columns. We usually call this M by N, where the rows are the number are the M value, and the columns are the N value. So if, for instance, we have 2 rows and 3 columns, that would be a 2 by 3 matrix. A lot of times we want to deal with what are known as square matrices or a square matrix. This just means the number of rows equals the number of columns. And anytime you have a square matrix, you can talk about the principal diagonal. It doesn't make as much sense if you have a non-square matrix, because again, the principal diagonal would be kind of the diagonal through the square. So if you were looking at a matrix that was a square matrix, we would be going from the top left down to the bottom right. Again, we usually put brackets around matrices. And if we want to look at a zero matrix, that just means that everything in the matrix is 0. And this is helpful when we're trying to do some of the operations on matrices. So example 1 here, we have a few matrices. We have 2 matrices that are set equal, and when 2 matrices are set equal, we can set each individual item equal to each other. So for instance, x is equal to 1, so we can figure that one out pretty easy. Similarly, we can kind of go through. 2y is equal to 6, so if 2y is equal to 6, then we know that y is equal to 3. And I want you to kind of complete the rest of this matrix by finding the variables given in the first matrix based on their corresponding terms in the second matrix. I want you to pause the video here and then go online to complete the corresponding homework problem for this video. Moving on to example 2, once you are done with that, very similar. Again, you are going to set each corresponding term. In this case, we have 2x plus y is equal to 2. And we have x minus y is equal to 10. And typically we use matrices to solve systems of equations. This one kind of does the opposite. It creates a little bit more work than we're used to. But in this case, if we have a system of equation, again, going back to what we've learned before, We're going to add these two systems because this plus y and minus y will simplify to be 0. So we've got 2x plus x is 3x, y minus y is 0, and this is equal to 12. So that will tell us that x is equal to 4 if we divide both sides by 3. And then we can plug this back into either. I'm going to plug it into the second equation because there's no coefficient on the x. And so if we plug that in, we have 4 minus y is equal to 10. So y ends up being negative 14, again, if you solve that equation. So this would tell us our x and our y values in this case. So again, I want you to pause the video here and try to work through example 3 in the accompanying assignment. And that will conclude the first lesson for this section.